Hey, what's up, guys? David Alex here for Ideas to Creations, and welcome to the Thinking Particles Basics video series. If you haven't watched the Espresso Prelude, you probably want to watch that. But if you're nice and comfortable in Espresso, then we can carry on. Okay, so here we are in Cinema 4D inside an empty scene, and let's get started. If you're used to your standard particles, you know that you just add an emitter, hit play, and there you go. But thinking particles work a bit differently. Thinking particles basically do exactly what the name says. They think, and it all depends on what they're doing, where they are, and all that stuff. So, for example, you can have a particle, say, once its age reaches a certain amount, then it can start flying upwards, or it can fly towards a specific object. You can make the particles follow a path. You can make them basically do anything you can think of. And the thing is, thinking particles may be powerful, but with great power comes great complications. And it's a bit of a hassle to set up. Actually, not a hassle to set up, but to get all those complex systems can be a hassle. So we'll just take a look at how to set it up basically in these first few videos, and then from then on we'll see what else we can do with it. So first thing I'll do is create a new null object, and I'm going to call it TP, which stands for Thinking Particles, and I'm going to right click Cinema 4D and choose Espresso. Now, Thinking Particles live inside the Espresso tag, so they cannot exist unless you have an Espresso tag somewhere, and the node workflow is what makes it very powerful. So in the under system operators in the expo, you'll find thinking particles and a whole bunch of sections. We have initiators, conditions, generator, standard, dynamic, helper, and this stuff. Condition is conditions. Generator is what we're looking for, and this is what produces particles. So we have two types that we want to look at right now. That's p-born and p-storm. P-born is basically the most basic of them all, because let me go ahead and set this to none, because once you hit play you can see it's creating particles, but they're not doing anything. It's just sitting there in the middle. And p-born is basically like for those of you who want control from the very beginning, and we don't need that right now. So what we need is a p-storm. Once you add the node in, p-storm is added, off it goes, producing particles, which are now represented by ticks. And that's about it, I guess. We now have an emitter, and just like in the other Espresso video, you can click on the node and then get a whole bunch of options here. You have count, you have life variation, speed variation, everything you'd expect to find inside inside a particle system. So those stuff I guess I don't need to go through. So one thing I'd like to show is what's count, rate, and short. We have different types here of emissions, which is birth type. Count is basically going to try and have this number of particles inside your scene at any given time. So in order to take a look at this, I'm going to go to Simulate, Thinking Particles, and go to Thinking Particles Settings. And this basically gives us a bunch of settings for them, and also how many particles are in our scene at this very moment. So right now we have 150 as our count and our life as 90, and we currently have 90 frames. So this means that by the point where one particle is dying, we want to have already that 150, so that any new particles that are produced are replacing that particle that just died. I hope that makes sense. It's only going to have a maximum of 150 in a given scene, and it's going to try and continuously emit. And so in order for that to happen, it can only emit particles at the exact same time when a particle is dying. So for this beginning, it sort of calculates a good rate where it's going to emit, so that by the time the first one's dying, another one's coming out, and we're at 150. So that's what count is for. And you can notice, like right now, if I take this down to like 2, it's going to take a long time before the second one comes out, and I'm going to set this to 180 as the maximum number of frames. And you'll notice as soon as this dies, you get another particle coming out. So it looks like it's sort of zipping back. So what we've told it is I want to have a maximum of two particles at any given time. So maximum. It'll go below for the first few seconds, but once you have something going, it works out pretty well. So that's count. Next is rate. Rate is emission per second, and take this down to 30, and currently our value is at 100. Let me put 20. So what it's gonna do is once every second it's gonna emit 20 particles. So as you can see, I've set this to 30, and if you go to project settings, you can see that our default frames per second is 30. So if you set this to 30, that's essentially 1 second. Actually, it's a second and a bit. It should be 29 because we're counting from 0. So once it hits that mark, you'll see it just hits 20 and then it loops. So that's how many we get. Let's do 29 times 2, which is 858. And you'll see this will go to about 40. So that's how that works. It's not just like the other one. It's more like how many particles are being emitted per second. Next is short, and short is particles per frame. Currently have 58 frames. You'll see that reaches about 58 and then it loops. So that's per frame, and you can go ahead and set like crazy values if you really need a lot of particles in a very short time. So there you go. That's short. And that's basically how those work. You can also change the type of emitter, a rectangle or a circle. So that's basically what those guys do. Now, I want to show you something interesting. If we take our null object, which is the one that holds our espresso tag, which is holding our particle emission, we can try and move this guy around, and we actually are moving him, but our particle emitter is not moving. That brings us back to this. And a very important factor when dealing with thinking particles. Unless you tell it to do something, it won't do it. And as vague as that sounds, it's the truth. So in this case, we are not actually telling the emitter. There's no place here that tells the emitter to follow the null. It has no reason to follow the null because nothing here tells it to do that. So we need to tell it to follow the null, and we'll use the same procedure as from the previous tutorial. So I'm going to bring in the node and just go coordinates, global position, and then I'm going to optimize it and tie it to this emitter position that's already there. And then now it moves, and now it follows the null. And if we actually, there's another thing. If we try and rotate this guy, you'll see it's not actually rotating. Same reason. It has no reason to follow the rotation. It only has to follow the position. So in order to do that, we need to go to the p-storm and add emitter alignment. And I'll optimize this. And then I'll go to the TP again and then add, let's see, what am I going to add? I'm going to add a global matrix. And we can optimize this and tie that to the emitter alignment. Now, this is also something I'd like you to know. It's that if you want it to rotate just like this with a null, you actually use global matrix and not global rotation. They don't work for some reason. I still don't know why. And, you just go with the flow. Just create these two and plat. It's pretty quick. So there we have our particle emitter. We can rotate it. We can move it. And that's about it for this video. In the next video, we're going to look at how to add dynamics such as gravity and all those other fancy things, as well as introduce you to particle groups. So I'll see you in that one.